I welcome you all for this video lecture series on operating systems. Today our topic is file allocation method. Before that, I introduce myself. Myself Shankar. I'm working as assistant professor in the Department of Computer Science and Engineering, RMD Engineering College, Chennai. Okay, so today topic is file allocation method. Okay, there are three major file allocation methods are there. One is contiguous allocation method, linked allocation method, and another one is indexed allocation methods. These are the major methods of allocating disk space in wide use. First, we'll see what is contiguous allocation method. The contiguous allocation requires that each file occupy a set of contiguous blocks on the disk. It's very important. That's why we called it as contiguous allocation, right? It requires each file copy a set of contiguous blocks on the disk. Disk addresses define a linear ordering on the disk. Disk addresses define a linear ordering on the disk. With this ordering, assuming that only one job is accessing the disk, access block B plus 1 after block B normally requires no head movement. Thus, the number of disk seeks required for accessing contiguously allocated files is minimal. Contiguous allocation of a file is defined by the disk addresses and length in the sense block units, right? So length of the first block. If the file is n block long and starts at the location B, then it occupies the blocks B plus 1, B plus 2, and so on, B plus n minus 1. The directory entry for each file indicates the address of the starting block and the length of the area allocated for this file. This is the example for contiguous allocation method. You just see, in this case, we have directory. In this directory, we have how many files? 1, 2, 3, 4, 5 files we have. The first file name is count. The first file name is count, and this is your disk space. Here we have blocks contiguously, right? So what I said here is, initially I said, right? You just remember the contiguous allocation requires that each file occupy a set of contiguous blocks on the disk, right? You just remember this. So here we have we have a disk space with 31 blocks. Initially the file count, the count is stored, it occupies 2 bytes. You just consider bytes or KB, whatever it may be, right? Is two blocks. We can call it as block. 2 blocks. The start blocks is 0 and the length of the block is 2. It means 0 and 1. So the count block takes 0, 1, totally 2 blocks. Right? The 2 must be continuous. Next file name is TR. The TR is allocated from the block size 14 to 3 length. It means that 14, 15, 16. You just see the 14, 15, 16. Continuously you should allocate the free space for the file. Right? So starting block is 14. The length is 3. So 3 blocks are allocated, namely called, the file name is TR. You should not allocate 14th start space, 1 block here, 1 block, this 14th block, 18th block, 25th block. That is not possible in contiguous allocation, because what I said, contiguous allocation requires that each file occupy a set of contiguous blocks on the disk. We should allocate continuously only. The next file name is mail, starts from 19. The length of the file is 6. So 19, 20, 21, 22, 23, 24. Just see, 19, 20, 21, 22, 23, and 24. This is allocated for the file mail. How many blocks? 6 blocks. You note down 1, 2, 3, 4, 5, 6 blocks are allocated contiguously. The next one is file name is list. List starts from 28. The size is 4. So 28, 29, 30, 31. Right? 28, 29, 30, 31 is allocated for if. Next, sorry, list. Next we have if. If starts from 6, takes 2 blocks. Right? The size is 2 blocks. It must be allocated continuously. Suppose continuously, for example, if you consider 6, if file name is 6, right, and its length is 12. You just see here, if it is free space, 6, 1, 2, 3, 4, 5, 6, 7, 8 spaces only we have free. From 6 to 13 is allocated, but the length is 12. In this case, we cannot able to allocate the file here. It must be how a continuous free spaces. Otherwise, we cannot able to allocate any file with this method. Right? And the next method is linked allocation. The next allocation method is linked allocation. Linked allocation solves all the problems of contiguous allocation. It means is if the free space is not continuously also no problem, we can allocate files with the different location, right? Is with linked allocation, each files are linked. Each file is a linked list of disk blocks. The disk blocks may be scattered anywhere on the disk, and the directory contains a pointer. This is very important, right? The directory contains a pointer to the first and last block of the file. You just see here. Here we have a directory. We have only one file, and these are all free blocks. All 31s are free. In this case, we are giving here starting value is 9. That file is allocated from 9th position. It should end with the 25th. That starting and ending only I have given, right? So the rest allocation blocks will be managed with the linked list. Right, you just see the directory contains a pointer to the first and last block of the file. Right, the disk blocks may be scattered anywhere on the disk. Right, you just see, so it goes to the start position 9. Right, and next block is till next block is 13. Right, it goes to the 13. 13 has the 1 minute. 13, sorry, 16. 9 has 16. It goes to 16. 16 have the value called 1. Right, then it goes to 1. 1 is having 6. It comes to 6. From 6 it has 25. Actually here only one digit is printed. That's why that's confusion. Okay, right, so this 9 consists 9 having block value 16. It goes for 16. 16 have the value called 1. It goes to 1. 1 has 10. Right? This is not 1. The value is hidden. 10. It comes to 10. 10 having the linked list called 25. It comes to 25. Here you just see it has mentioned minus 1. Minus 1 indicates it is the end value. Minus 1 indicates end value. What we have specified here, end value is 25. So 25th block having minus 1. Up to this the file is over. Right, so like this the memory is allocated for the disk space for the file. The next one is indexed allocation. Indexed allocation solves the external fragmentation and size declaration problems of contiguous allocation. However, in the absence of FAT, linked allocation cannot support efficient direct access since the pointers to the blocks are scattered with the blocks themselves all over the disk and must be retrieved in order. Indexed allocation solves this problem by bringing all the pointers together into one location. That location is indexed block. Each file has its own index block, which is an array of disk block addresses. The ith entry in the index block points to the ith block of the file. The directory contains the address of the index block. to find and read the ith block. We use the pointer in the ith index block entry. This is the example. For example, the same, right? We have a file name called zip. The index block is 19. In this index block, it mentioned that 9, 16, 1, 10, 25, minus 1, minus 1, minus 1. Right? You just see here what initially they said. 1 minute. Scattered blocks themselves all over disk must be retrieve the order. Right? Is no, this one. Index allocation solves this problem, bringing all the pointers together into one location. That one location is index block. So this is the index block. This is the index block, right? That is 9. Sorry, 19. So initially, what happened if we have a file? In this file, it goes to 19. 19 is the index block. Index blocks contains all the pointer together into one location where the files are allocated. So if it went to 19, where the files are allocated? First one is 9. It goes to 9 for one block, right? For one block. And next one is 16. Where is 16? It goes to 16. 16 is another file block. And next one, it goes to 1 for another file block. And next 10, it goes to 10. And next 25, it goes to 25. That's it. The remaining minus ones are indicates that ends. There is no more file allocations are there, right? So like that, the file disk space is allocated through index allocation method. I thank you all for watch this video lecture series.